This is lesson 6.2, solving inequalities using multiplication and division. First, we're going to look at the multiplication property of inequalities. And what this says is that multiplying each side of an inequality with a positive number will produce an equivalent inequality. Conversely, if you multiply each side of an inequality with a negative number, you need to reverse the sign to produce an equivalent inequality. This means that if A is less than B and C is greater than 0, then AC is less than BC. And if A is less than B and C is less than 0, then AC is greater than BC. You need to note here how the sign reverses when you're multiplying by a negative number. In the greater than examples, if A is greater than B and C is greater than 0, then AC is greater than BC. And if A is greater than B and C is less than 0, then AC is less than BC, because again, the sign reverses when you multiply by a negative number. So for example, if we have x divided by 4 is less than 5, to solve this, we'd multiply each side by 4. When we do this, we get x is less than 20. There's no need to do anything to change the sign here because we multiply by a positive number. The sign is not going to change. So to graph this on the number line, you'd put an open circle on 20, because remember, it's not included in the solution set, and we draw the arrow to the left-hand side to note that x is less than 20. If you have x divided by 3 is greater than 8, to solve this, you'd multiply both sides by 3, and you get x is greater than 24. Again, there's no need to change the sign. You would draw an open circle on 24, and you would draw the arrow to the right hand side because x is greater than 24. That means every number to the right of 24 would be included in the solution set. And you should always check your answer back to your original inequality to make sure that this works. In the next example, m divided by 8 is less than or equal to negative 2. We're going to multiply by 8 to solve for m. So we get m is less than or equal to negative 16. Don't be thrown by the fact that there is a negative in this inequality. It's only when you multiply by a negative that the sign changes. And then you can look at the last example. It follows the same pattern as the one we've looked at. Now let's take a look at what happens when we multiply with negative numbers and how we reverse the sign. When we have x divided by negative 6 is less than 7, you need to multiply each side by negative 6 to solve for x. When you do that, you get x on the left-hand side, but you have to reverse the sign of the inequality to make it greater than, so it becomes x is greater than negative 42. On the number line, you draw an open circle on negative 42, and you would draw the arrow to the right-hand side, since x is greater than negative 42. Try a number that's greater than negative 42 in the original inequality and make sure it works so that you can check your answer. In the next one, you have the opposite of x divided by 5 is greater than 10. To solve this, you'd multiply by 5, so you get the opposite of x is greater than 10. But to solve for x, you need to multiply by negative 1. When you multiply by a negative number, you have to reverse the sign. So x is less than negative 10. Again, you're going to draw an open circle on 10 and draw the arrow to the left since it's a less than sign. You can also use division to solve inequalities. And again, division is just like multiplication. So dividing by a positive number will produce an equivalent inequality. But if you divide by a negative number, you need to reverse the sign to produce an equivalent inequality. So whenever you're multiplying or dividing by a negative, the sign has to change. In the first example, negative 3x is greater than 24. You would divide by negative 3 to solve for x. When you do that, you get x is less than negative 8. You have to reverse the sign because you're dividing by a negative. So to draw this on a number line, you draw an open circle on negative 8. And because x is less than negative 8, your arrow would go to the left. In the next one, negative 6n is less than negative 36. To solve it again, you divide by a negative number, that's negative 6, and when you do that, you have to reverse the sign. So you end up with n is greater than 4. Try the problems below to make sure that you can do these. You shouldn't be getting confused when you do them at all. It's only when you have an inequality that the sign changes, of course. It doesn't affect anything when we're working with equations. Let's take a look at a simple word problem. If you need to spend 80 hours training for a triathlon and you're paying your trainer a rate, we'll call that R, and you only have $6,000 to spend to get ready for the triathlon, I'd like you to write an inequality to show the possible hourly rates that you can afford. If you need to spend 80 hours and the rate is R, then 80 times R would be the amount of money that you will be spending on training, right? So we have to set that less than or equal to your budgeted amount, which is 6,000. So you'll end up with an inequality that's 80R is less than or equal to 6,000. When you divide both sides by 80, you get R is less than or equal to 75. Because we divided by a positive number, you don't have to tweak the sign at all here. So R is less than or equal to 75, and what does that mean? It means you can afford to spend $75 per hour on training, but that would take you to your maximum budget.